Okay guys, I'm just going to keep rolling through practice problems, but first, just to get warmed up here with this video, you guys try to do this one on your own. I'm going to walk through it here, so go and pause this, do this in class. This is an easy one to get warmed up with, so if you do this one, then we can keep going from here. So you pause the video and work on this. I'm going to go ahead and do it now. So here we go. First thing. With this problem, again, this is the same section. We're still going to try to use substitution to integrate this thing. All right. So the substitution I'm going to use, what we always look for is there any function that I can, if I take the derivative of it, I will get something similar to what another expression that I have in my function. And there actually is. And it's actually not even going to be similar. It's going to be the exact same thing. So hopefully, when you guys did this, you let u equal x cubed plus 4. It's going to make things a lot easier if we do it that way. Alright, so if u is equal to that, now hopefully you guys got the hang of this so far. Yes, I would take the derivative of both sides, but what I'm doing is I'm going to take the derivative of both sides and multiply by dx at the same time. So this is going to be 3x squared dx. Okay, so to run through this real quick, so let me rewrite this again, the original equation. It's going to be x cubed plus 4 cubed times 3x squared and then dx. Alright, I think that's it. Yeah. So what we can do from here is go ahead and substitute what u is. Well, we know u is what we let inside here. It's x cubed plus 4, so it's going to be u cubed. But this whole thing right here is going to be what? It's du. Okay? So really we've got u cubed du, and we just got to work from there. So this is, like I said, this is pretty simple as long as you let u equal the right thing. And so now, just using the antiderivative, you add 1 to the exponent, divide by the new exponent, so it's u to the 4th over 4, and then the du goes away when we actually take the antiderivative. But the one thing I'm forgetting is my plus c. Okay, so the only thing left to do is to plug in what u was initially, which was, hang on, let me make sure, it was x cubed plus 4. So it's going to be x cubed plus 4 to the 4th over 4, and then we got plus c. That right there is my answer. Okay, circle that, we're done there. So like I said, hopefully that you guys found that to be easy for that example. Okay, that was a warm-up. Okay, let's do another one, guys. And it's just going to take practice. So I'm keeping doing examples because it takes practice understanding what to let u equal. So here we go. It's easier the more we do it. So here it is. So find the indefinite integral. So I've got multiple examples here. I actually think I'm just going to do part A and part B. Alright, so here we go. Now, I went ahead, the example is this, guys, but I went ahead and rewrote it like this, just so you guys can understand this is the same thing. If I have dx over the cosine squared of 2x, then the dx is in the numerator, but I can always just bring it right off to the side and write it as this is just dx over 1, isn't it? So we can write it off to the side because of that. It's just properties of fractions, guys. If we have, like for example, if we have 4 over x, that's the same thing as 1 over x times 4. Okay. So I just rewrote it like this, just to hopefully keep you guys from any confusion here. All right. So let's go ahead and get through this one here. We'll go through this one together. So first of all, if you want to solve something like this, if you want to integrate something like this, one thing to notice is we got 1 over cosine squared of 2x. Alright, so one thing to notice is a little bit of maybe use a trig identity here. Okay, going back all the way to advanced math. So if you look at 1 over cosine squared of 2x, isn't that the reciprocal of cosine squared 2x? So if you think about reciprocals, what is the reciprocal of cosine? And when we talked about it in advanced math, it was secant. Okay, so we can rewrite this as the integral of secant squared of 2x dx. Okay, rather than writing as 1 over cosine squared 2x, that's the same thing as secant squared. Now, the reason I did that, guys, is because if you look at your formula page, I'm holding it up here, I'm making sure, yeah, right there, hopefully you can see it. Secant squared of 2x dx. We know the formula. We know what that's going to give us, the integral of it. So the integral of that is tangent. So before I do anything, though, I'm not going to apply that yet. I have to use substitution. So rather than, if you look at your formula here, it says secant squared of u du. Well, in this case, we have secant squared of 2x dx. So I would probably want to let u equal 2x in order to get it to look like that formula so I can use that formula. Okay, so guys, if we let u equal 2x, what is the derivative of u? Well, du is going to be 2 dx. Okay, so I'm going to replace this. So over here, I'm going to replace this. Let me do this in red. So this is going to be the integral of secant squared of u. And we still have this dx, don't we? Well, guys, I want dx, and hopefully you can see what we need to do here. Just like we've done in previous examples. Well, we want to make this guy look like du. Well, du, we said, is 2x. Okay? So if we want to make this look like du, well, we don't have and I think I misspoke. It's 2 dx. Okay? Du is 2 dx. So I want to have a 2 right here. So I'm going to put a 2 right there in front. Now, I can't just do that all willy-nilly and expect that to be okay. Like, that changes the value. So I need to counteract that. So remember how we did that? In order to counteract this, we can multiply by 2 as long as we multiply by 1/2 at the same time. Okay? Those are going to counteract each other. What's 1/2 times 2? The answer is 1. Guys, I can multiply by 1 as much as I want. Okay? So all we've got to do now is, well, before we use the formula, we got one more thing to look at. So this is going to be 1/2 of the integral of secant squared u. And then we can rewrite 2 dx as du. So now that we've got that, we can apply the formula exactly. Alright, so look at the formula. Secant squared, the integral of it, is tangent, it looks like. Yeah, tangent. That's because the derivative of tangent is secant squared. I don't know if you remember that from when we talk about derivatives. But anyways, the antiderivative of secant squared u is going to be tangent u. And then we're going to have this plus c. Always remember your plus c. Remember the du goes away when we take the antiderivative. Okay? And then really we're pretty much done. We just have to plug in what we let u equal. It's going to be tangent of, what is that? What do we let u equal? 2x, yeah. Plus c. That's the answer. Okay. There's another one. Moving along, let's do another. Here we go. Here it is. This one's going to be a little bit more difficult. I'm just going to go and explain to you this one. Let's go through this one together because you might not understand what to do. If you guys look at your formula page, cotangent squared I don't think is on there. We would like to be able to use a trigonometric formula here for integration. So what I'm going to do is, instead of writing this as cotangent squared of 3x, I'm hoping this doesn't confuse everybody. If you remember back to advanced math, we talked about Pythagorean identities. So just think about this, see if this rings a bell. Didn't we say sine squared of whatever our angle is, we could call x, plus cosine squared, x is going to equal 1. Remember when we did that? We did a lot of identities and trying to solve and simplify identities and things like that in advanced math. So one of the identities, so the way we can figure out other identities is to divide every term by either sine squared or cosine squared. Let me divide everything by sine squared here. So guys, this was the major Pythagorean identity. Okay, sine squared plus cosine squared equals 1. Hopefully we at least remember that. So I'm going to try to get to you, I'm going to try to explain to you why this next identity is true. Okay, I want to use an identity here and replace cotangent squared of 3x with it. All right, you guys will see why in a second. So what if I divide everything by sine squared? Okay, that means I have to divide both terms by sine squared. Or sorry, all three terms by sine squared. Okay. So what is sine squared divided by sine squared? The answer is 1. What's cosine squared divided by sine squared? Well, that's the same thing as cotangent, hopefully. You guys understand that. So it's going to be cotangent squared of x. And that's equal to 1 over sine squared, which is cosecant squared x. Remember, the reciprocal sign is cosecant. Okay, so hopefully that rings a bell, this next identity. So if we want to solve for cotangent squared here, just got to subtract 1. Okay, so cotangent squared x is going to equal cosecant squared x minus 1. This is an identity that we've used before. So guys, I'm going to replace this. Instead of calling it cotangent squared of 3x, now this is just x, but whatever your angle is, the identity still applies. So I'm going to rewrite this one as the integral of cosecant squared 3x minus 1 dx. Because cotangent squared is the same thing as cosecant squared minus 1. Alright, so that's going to help us out a lot. The reason that helps us out a lot is because we have a formula for cosecant squared. Look at it, formula page, right here. There it is again. So cosecant squared, the formula for it is negative cotangent. But before we do that, we need to use this. The formula tells us cosecant squared of u. All right, this doesn't look like u, so we're going to let u equal 3x. Okay, and so that means du is going to equal 3 dx. Again, I'm just using a shortcut here. This would be du over dx is equal to 3, and then multiply by dx to both sides. Du is going to equal 3 dx. Okay, so to rewrite this, it's going to be the integral of cosecant squared of, instead of 3x, I'll go ahead and write it as u. Okay. Minus 1. Okay. Dx. Alright. Now hang on a second here, guys. Let me kind of adjust this here. So using properties of integrals, let me just rewrite, let me rewrite this function here. So let's keep it as 3x. Okay. So using properties of integrals to keep this squared away so we don't have to worry about this minus 1 dx. Don't let that confuse you here. Properties of integrals, we can rewrite this as cosecant squared of 3x minus the fix this, dx minus the integral of 1 dx. Okay? Whenever we subtract, this is one of the properties of integrals that we know. Whenever we subtract two things, that's the same thing as taking the integral of the first guy minus the integral of the second guy. Okay, so hopefully that's all right. So I'm going to come back, I'm going to use this. Now, guys, we should know how to integrate 1, okay? Add 1 to the exponent, divide by it. So it's just basically going to be x, which we'll get in a second, okay? But let's really focus on this. This is the goal here. So we let u equal 3x, didn't we? So I'm going to let this be cosecant squared of u dx, okay? Now, why don't we just go ahead and take the antiderivative of that? So this is going to be minus x plus c. All right. So the antiderivative of 1 is just x. Okay. This is going to be 1x to the first over 1. Hopefully that makes sense. All right, let's keep it going. So this guy right here. So we're just... Okay. I'm sorry, guys. I just don't want you guys to get confused here. Let me make sure we know that we're not gonna subtract this. This right here is by itself. We need to take the antiderivative of this. How about we just don't worry about this yet? We'll come back and fill that in. Okay, so let's come back and fill it in a second. I just don't want you guys to get it confused here. All right. So here we go. I'm gonna try to make this look like what we had. Excuse me. Sorry. I want to try to get this over here to look like du. I want to write du in here. Okay, so I'm trying to replace, I'm substituting u, yes, but I also want to replace du inside here. Guys, let's look back at what du is. Du is equal to 3 dx. Well, right now, we just have a dx. So I could put a 3 in here as long as I multiply by what outside? The answer is 1/3. Okay? So I can't just multiply the 3 and change the value. I have to counteract that by multiplying by 1/3 simultaneously. Okay, so now we can go ahead and, well, Getting a little ahead of myself again. I'm sorry guys, this is not the best explanation. Cosecant squared of u, and then this 3dx, that is the same thing as du. So I can go and replace that with du. Alright, and then minus the integral of 1 dx. Okay, so let's go ahead and take the antiderivative of this guy, and we've got a formula for it. So let's use it. The formula is negative cotangent of u. Alright, so it's going to be times negative cotangent of u. And then if you want, you go ahead and put the plus c here. Okay? And then let's go ahead and take the integral of this guy now. So let's antidifferentiate here. So we've already mentioned that the antiderivative of 1 is just x. And if you want, you could put another plus c. There's nothing wrong with that, I guess. Because, guys, when you add all the constants together, you're still going to have some constant. We'll get to that in a second. So now what I'm going to do is I'm going to replace u with whatever u is equal to. So this is going to end up being negative 1/3 cotangent of u in this case was 3x. And then we've got this plus c. But guys, when we multiply the 1/3 times c, that's still a constant. And then when we add this constant, it's still a constant. So it's going to be plus c. And then we still have this minus x. And that is our answer. Okay. So hopefully you followed that. That one wasn't very clear. I didn't do a very good job of explaining that. But I'm not going to edit this out. You can always rewind it if you need to. Okay. Got to keep rolling here. Got about 16 minutes in. So let's see if we can do 1 or 2 more problems. Might just have to be 1 more. We'll see. All right. So here goes. Here's the next one. I think. Yeah, right here. All right, so this one right here, still same thing. We're going to use substitution here. So again, our goal, this is a function with respect to x. We want to try to write this as a function with respect to u du, okay, rather than x dx to make this simpler. So let's just let u, and try to answer this, guys. What should we let u equal to in here? I think we should let it be 2x squared. Okay. The reason for that is when I take the derivative of it, I'm going to get something similar to x. Okay. So du is going to be 4x dx. So instead of just x, we've got 4x dx. So we'll take care of that in a second. It's not a big deal. So here we go. I'm going to rewrite this as the integral of x times the cosine. I'm just going to rewrite it. Okay. I'm not changing anything. 2x squared dx. Okay, and I'm gonna just change the order here before I do anything else to make it make sense. So this is going to be the integral of cosine of 2x squared times x dx. Now, what we want to do is we want to get this to look like 4x dx. But hang on a second. Let me plug in u. So this is just cosine 2x squared. We let that be u, right? So it's going to be cosine of u times x dx. Now, like I said, we want to get that to look like 4x dx. Okay, so let's put a 4 there. What do we have to do at the same time? Multiply by 1/4. Okay? And so now, we can rewrite this. This is 1/4 times the integral of cosine u. And then this whole thing is du. There it is. So we should know what the antiderivative, without even looking, what's the antiderivative of cosine? The answer is sine. Sine of u plus c. And then I need to replace what u is. So 1/4 sine of 2x squared plus c. There's that one. All right. If you need to see anything else, go back, rewind it there. All right, now this next one is going to be kind of lengthy, so let me get this started. This one's a little different, so there's just something else you can do here. All right, here we go. So the integral of 5x times the square root of 2x plus 3 dx. Now this one's a little bit more challenging, and I'll explain this as I go through it. Write that guy down, we're going to try to solve it here. So here we go. This one, you really can't, if you let u equal something, the derivative is not going to be similar. Doesn't matter what you let u equal to. The derivative is not going to be similar to another expression. All right, so let's try to make this easier on ourselves. Sorry, I got a text. All right, so let's try to make this easier on ourselves. And the square root, just let u be whatever's under the square root. Okay. The reason for that is because, well, if I let u be 5x, then that doesn't make things much more simple. Okay. Letting u, like, taking the square root of 2x plus 3 is a lot more difficult to think about than just taking the square root of u. Okay, so that's what we're going to do. We're going to let u equal 2x plus 3. So therefore du is going to be, I think, 2dx. Yep. Just take the derivative of that. Derivative of 2x plus 3 is 2. Okay. All right, so then what we would have is this. It would be the integral of 5x times the square root of u dx. Okay, so that's the issue, guys. We're not going to be able to make 2dx look like 5x dx. All right, so that's the issue that I'm running into. So guys, let me show you kind of a trick here that you can do if you run into that. All right, so here's the trick. Everybody see this equation we let u equal to? It's going to be 2x plus 3. What if I rearrange that? What if I figured out what x is? What if I found x with respect to u? Okay, so what if I rewrote x as an equation with u in it? Then we'd have all u's in here. That might help us out a lot. So let me explain what I mean by that. So off to the side here, u is equal to 2x plus 3. What if I wanted to solve for x? Okay, so let's do that. If I solve for x here, well, let's try to get x by itself. So let's subtract 3. So off to the side, let's do this. So this is going to be u minus 3 is equal to 2x. Okay. And then to get x by itself, I need to divide by 2. So x is going to equal u minus 3 over 2. So I'm going to replace x with u minus 3 over 2. And then this is going to be u to the 1/2 power, isn't it? The square root of u. And then we still have this dx though. Okay. Well, what we could do, well, we want to try to get dx to look like du. So what I could do is I could put a 2 in front of here, couldn't I? Hopefully that makes sense. If I put a 2 in there, what do I have to do to the outside? Well, multiply by 1/2. There we go. And so now I'm just going to rewrite everything. So this whole thing right here is du. Okay, so I'm just going to rewrite everything. Like I said, it's going to be 5 times u minus 3 over 2 times u to the 1/2 du. Okay, now all we got to do is just simplify. Now we've got a function with u's in it, du. Okay, we got a function with respect to u du. So now all we got to do, let's simplify it before we integrate it. And of course, it's frozen on me. So, shoot. Well, if you need to go back at any point, I'm going to have to X out of this, so you're going to have to rewind the video to do this. So it's going to freeze. I'm going to write what I had as my next step here. Let me bring this up. I don't really need to go back to that, so let me write what we had that last step. So here it is. Okay. It was 1/2 times the integral of 5 u minus 3 over 2, and then it was u to the 1/2 du. Okay, so before we integrate this, let's just simplify. All right, so here goes. I'm going to change the way this looks. I'm going to rewrite this. It's going to be 5u to the 1/2 times u minus 3 over 2 du. This is still 1/2 times that. Okay, here we go. Let's keep it going, guys. So I need to distribute this. I've got this times this. Now this is over 1. Hopefully everybody sees that. So I'm just going to simplify here. I need to distribute. So take 5u to the 1/2 times u. Now one thing I want to point out, u is to the first power. So isn't that the same thing as to the 2/2, to 2 over 2 power? Okay, think about that. So when you multiply these, you need to add the exponents. So guys, what we're going to have is the integral of 5u to the 3 halves, okay? U to the 1 half times u to the 2 halves, or 2 over 2. 1 half plus 2 over 2 is 3 over 2, okay? And then we have minus 5u to the 1 half times negative 3 is negative 15u to the 1 half. All over 2 du. Now, do you guys like working with fractions? Probably everybody said no. So let's try to get rid of that 1 half. Can we move this is just a coefficient, isn't it? It's just a constant. So can we move it out here? This is 1 half. 1 half times all this stuff. So since I have a 2 on the bottom, I can rewrite it as 1 half being multiplied out here. So if I multiply 1 half by 1 half, I get 1/4. And then I don't have to deal with any fractions. Okay, so now it's pretty simple to find the antiderivative. You're just going to need to add 1 to the exponent, divide by the new exponent. So when I add 1 to the exponent, I need to add 2 over 2. So therefore, this is going to be 5, and we still have this 1/4. It's going to be 5u to the 5 halves divided by my new exponent, which is 5 halves. Okay? Minus 15u, when we add 2 over 2 to this exponent, it's going to be 3 halves divided by 3 halves. Okay, and we're going to have a plus c. It doesn't matter where I put it. I can put it inside parentheses or outside of it. Okay? All right. So, just simplifying a little bit more. Instead of division by 5 halves, I can multiply by 2/5. 2/5 times 5 is just going to be 2. Okay? Instead of dividing by 3 halves, I can multiply by 2/3. 2/3 of 15 is, I think, 10. Yep, that looks right. 10u to the 3 halves. We still got this plus c. And what I'm going to do is multiply by 1/4 through here now. So let's multiply everything by 1/4. So this will end up being 1 half u to the 5 halves. And then 1/4 of 10. Oh, come on. Yeah, let's just call it 5 halves. 1/4 of negative 10 is negative 5 halves. Okay? 10 over 4, reduced to 5 halves. Then we got u, let's just write as u to the 3 halves, and then plus c. Alright, and then I'm just going to replace what u was. What did we let u be all at the beginning? It was 2x plus 3, wasn't it? Okay, so it's 1 half times 2x plus 3 to the 5 halves, minus 5 halves times 2x plus 3 to the 3 halves. And again, just for good measure, guys, I'm not going to do this, but how could you check your answer, see if you got it right? We just took the antiderivative there, right? So if you wanted to, you could take the derivative of that and see what you get. Actually, I'm going to have you do that. So in class, after you're done watching this video, find the derivative of this and see if it works. Okay. Find the derivative of our answer. So take the derivative of that and see if it gives us what we started with. Okay, I'll stop right there in this video here.